Hi there. Now in this question we're given the birth weights in kilograms of 1,500 babies and they're summarised in this table here. We're also given these summary statistics, sigma fx equaling 4,841 and sigma fx squared equaling 15,889.5. And we've got to write down the missing midpoints in the table above for 2 marks and then go on to calculate an estimate for the mean birth weight for 2 marks, and finally in part C calculate an estimate of the standard deviation of the birth weight for 3 marks. So if you'd like to have a go at this, I'll just give you a moment to pause the video. When you come back, you can either fast forward just to check over all my working, or I'll take you slowly through the answers. Okay, welcome back then if you had a go. So the first thing we need to do then is write down the missing midpoints in the table above. So we've got this class interval 2.5 to 3, so the midpoint here is just going to be 2.75. And for the midpoint of the class interval 5 to 6, that's going to be 5.5. I'll put it in as 5.50 because it looks like we're working to 2 decimal places. So the next part, in part B then, we've got to calculate an estimate of the mean birth weight. So the estimated mean, we'll just have an intro here. It's not the true mean purely because we are working with continuous data and it's in class intervals here. So I'm just going to write estimated mean, and that estimated mean I'll call x bar, and it's going to be equal to the sum sigma of fx all divided by sigma f. Okay, formula we should be familiar with. And working this out then we end up with, well, we got 4841, and that's divided by the total frequency, which if you added this up comes to 1,500. So divide that by 1,500 and you end up with 3.2273 and so on. And if we give our answer to 3 significant figures, it's going to be 3.23 to 3SF. Just squeeze that in there. Okay. Now in part C we've now got to calculate an estimate of the standard deviation of the birth weight. And if you're going to work out the standard deviation, I'll just abbreviate it to standard dev, okay? Then again we should be familiar with this particular formula, that it's going to be the square root of the sum sigma of fx squared, and that's divided by the total frequency sigma f, and we subtract the mean squared. So we've got our values for this. It's going to be then the square root of all of sigma fx squared, we've got that here, 15889.5. Divide this by the total frequency, which is 1,500, and we subtract the answer we just found earlier. Okay, I'll put the unrounded version in, that's 3.2273 and so on, and we square that. And if you work that out, you end up with 0.421093 and so on. Giving this to 3 significant figures, it's going to be 0.421 to 3 significant figures. Okay?